solve for x if we're given that log base 9 of x plus log base 9 of x minus 8 is equal to 1. Now the way we solve this is by using the properties of logarithms. So for example, on the left side we can use the product property for logs that says if you have log base b of a product, that's equal to the sum of the logs. So this is going to be log base b of x plus log base b of y, which looks like the left side of our equation, right? So what we can do is that we can combine the x and the x minus 8 through product. So what this becomes is log base 9 of x times x minus 8 is equal to 1. And so now the best way to solve this is to write it in exponential form. Since in exponential form it's going to be easier for us. So let's recall that if we have the equation y is equal to log base b of x, that's the same thing as saying b to the y is equal to x, right? So in this case, let's relate this blue equation here with what we've got over here, and 9 is equal to b in this case, right? And our x is actually this x times x minus 8, and our y is equal to 1. So now that we've related it to the expression, the blue expression on the left, let's try changing it to the blue expression on the right. So what this equation becomes is b to the y, so 9 to the first power, right? Oh, excuse me, I actually meant to write y here. Sorry about that. So b to the y, so 9 to the first power is equal to x, and our x is this expression x times x minus 8. So now we need to simplify and solve for x, right? So 9 is equal to x squared minus 8x, and since this is looking like a quadratic equation, let's subtract both sides of the equation by 9. So we get 0 is equal to x squared minus 8x minus 9. So now we have a quadratic equation, and let's try to factor it. So if we try to factor it, we get x minus 9 times x plus 1 is equal to 0, right? Since negative 9 times 1 is negative 9, and negative 9 plus 1 is negative 8. So, using the zero factor property, we know that x minus 9 is equal to 0, so x is equal to 9, or x plus 1 is equal to 0, so x is equal to negative 1. So these are our proposed solutions, but the next thing we have to do, the last thing we have to do, is to check both solutions, because we may have acquired extraneous solutions through our process. So we want to check by plugging in x is equal to 9 and x is equal to negative 1 into the original equation, right? So let's go up and see what the original equation was. So log base 9 of x plus log base 9 of x minus 8 and we want to make sure that that's equal to 1. So plugging in both, let's plug in x is equal to 9. So log base 9 of 9 plus log base 9 of 9 minus 8, and we want to see if that's equal to 1. So by properties of logs, log base 9 of 9 to the first power is going to equal 1. And this becomes log base 9 of 1, and any log base anything of 1 is always going to be 0. And as it turns out, these two guys are equal. So x equals 9 checks. So now let's try x equals negative 1. So we want to try log base 9 of negative 1 plus log base 9 of negative 1 minus 1 to see if that's equal to 1. Now notice that in both cases we have log base 9 of a negative number, but the logarithm of a negative number is not a real number. So in this case, our x minus 1 does not check out as a solution. So the only solution is x is equal to 9.